greetings to everybody around the globe here joining us today. Now I have the pleasure to introduce Uku Erik Tropp. Uku is a bioprocess development at Fibenol based in Estonia, and Uku will tell us about their wood refining and what crazy biochemicals and biomaterials they can develop through their unique process. Uku, with that, over to you.
Hello from my side. Thanks for the introduction. A couple of words about myself. So, yes, as already said, I'm working on bioprocess development at Fibenol, and today I'll be talking about wood biorefining. But in general, I have a background in chemical engineering, and I previously worked in the polyurethane business, and now with biomass. And working with biomass is quite interesting because we actually have quite a large problem to solve in the world. And the problem is that fossil-based chemistry is not sustainable. I'm sure you've all heard too much about global warming and CO2 emissions and all that. So I won't dwell on that for long, but I'd just like to bring out some numbers just for reference. So here I've taken two common chemicals, so phenol, an aromatic fossil-based chemical, and polyethylene, and the CO2 footprint for the production of both of those materials is approximately 3 kilograms of CO2 equivalents per 1 kilogram of product. And should we burn products that are made of those materials at the end of their life cycle, then that would result in an additional 3 kilograms of CO2 emissions per 1 kilogram of product. So that already shows that quite a lot of carbon emitted when producing and using materials. But we'll come back to those numbers at the end of the presentation, so keep them in mind. But anyway, one solution to reduce emissions from the chemical industry is making materials from biomass. This is not a novel idea. So the cellulose and pulping industry has been around for well over 100 years. But the problem with the cellulose industry is that it only focuses on cellulose. However, there are many other components in wood, namely lignin and hemicellulose. And in the pulping industry, they are normally burned just to get energy to separate the cellulose. And that means that actually less than half of a tree is valorized. And here at Fibenol, we aim to do things differently. So we aim to extract all the good stuff that you have in wood. So lignin, cellulose, and hemicellulose in one way or another, so that more than 90% of a tree would be valorized. For our source material, we use wood residues. So if we think of a tree and think of a nice round long log that could be used in the furniture industry or construction industry, then that's not the material we want. But instead, we make use of the residues that are left over from forestry, from sawmills, from plywood industry. We use that as an input in our biorefinery, and then we fractionate wood into different chemicals. So that would be lignin, cellulosic sugars, and microcrystalline cellulose. This whole idea started back in 2016 when it was just an idea on a paper, but now, some years later, we're already on the verge of commissioning our biorefinery. And that takes place here in Estonia, in Imavere, which is right about in the middle of Estonia, so about an hour's drive from our capital, Tallinn. At the heart of the biorefinery is a novel pre-treatment technology. This is something that we're licensing from one American company named Sweetwater, and it's unique, one of a kind, and we are the ones that are scaling it up to an industrial scale. What this technology does is that